So continuing, so we have 6 factorial ways. 6 factorial, I mean to say, assuming we are to. So of course we write out the natural numbers or integers in a progressively decreasing form. Now also note, okay, let me call it number, or do I say note? Note, very important, that 0 factorial is 1. Very important, it's accepted. That 0 factorial is 1. That will be proven some other time. Okay, so that is how we have. Now, you might see, let's say, let me call it number 4, and then you are told to do, say, n factorial. N factorial. How do we express it? Of course, remember that 6 factorial was in a very decreasing form, and then 4 factorial, the same thing. We went in a decreasing manner. So n factorial, and all of them were decreasing. If you notice, they were decreasing using 1, 1, 1. Then this one also 1, 1, 1. Of course, that means we are saying 5. Then 5 minus 1, 4. 5 minus 2, 3. 5 minus 2, 3. 5 minus 3, 2. And then 5 minus 4, 1, like that. Okay, so we are going to bring in the same concept here. So if that's the case, then n factorial is, then we have n itself times, then n minus 1, then n minus 2, in that manner, then n minus 3, and so on until we start getting to say 2, then times 1, and order. Of course, it ends in that order till 1 factorial. So if I have, say, let me call it number 5. If I have, say, for example, you have sorry for that, you have, say, 4n factorial, for example. How is it going to be? So of course, let me say having 4, then times n times, of course, n minus 1 times n minus 2, in that order. So we are treating the one that is closest to the factorial. So continuing to 2 times 1, 3 times 2 times 1, as the case may be. How about if we have like 6? What is it going to be? Number 6. Number 6. What if we have like 4n factorial all together? What would this one be? Now, since the factorial is for the both multiplied product, so it's going to be 4n times 4n minus 1. Remember, the decrease in is, we're decreasing by 1, times 4n minus 2, and so on till you have 2 times 1. I hope you're getting it now. Okay, how about if we have, say, let's say number, let me call it 7. Okay, let me use space, let me skip, say 7. What if we have, say, 6 factorial all over 4 factorial? How are we going to do this one? So it's going to, now we notice that now what we must do to make it quicker is reduce the one that is the biggest. So 6 factorial is bigger than 4 factorial. So we must reduce, don't waste time by reducing the both. So we reduce by, that means 6 times 5 times 4. You see, well, I've gotten to the one that is smallest. So reduce the biggest one. Leave the smallest one. Don't start reducing all of them. Yes, you can reduce and cancel out, but you are wasting time. So simple. So our answer is 30. You see? So that's how you do it. Now, let's say you have, say number 8, say 10 factorial. You are doing, say 9, or do I say 7? So the same thing applies. 10 times 9 times 8 times 7 factorial. Leave the smallest one. So you get your answer. You get the point. So that's just what you do. Are you getting me now? Okay, so that's what you do in that case. Now, how about if it is, say number 10, okay, number 9, you're told to get this, n factorial all over n minus 1. Now what are you going to do in this case? Now which of them would be the bigger one? I think the one up is likely going to be the bigger one. You get the point? So the one up is going to be the bigger one. So in that case, we're going to reduce the one up. So let me say have n times n minus 1. Now the one down is, so we have gotten the match with the one down, n minus 1. So we can cancel. So our answer is n. Get the point? So that is how we do that. Of course, this one should be 720. That's 9 times 8, 72 times 10. So that's how we have it. Thanks. So we'll continue in the next video.